You know, most people think they understand sound. They really do. They think sound is just, well, it is what it is. Air molecules bouncing around, hitting your eardrum, and boom, you hear something. Simple, right? But here is the thing that absolutely blew my mind when I was younger, and I have been thinking about physics my whole life. The thing that nobody tells you, the thing that makes sound one of the most peculiar phenomena in all of nature, is this. There is no such thing as sound traveling through space. I mean, really think about that for a second. The sound is not actually moving anywhere. Now I can see you scratching your head already. You are thinking, wait a minute, Feynman. I shout across the room, and someone hears me. Something must be traveling, right? And you are absolutely correct to think that. But what is traveling is not what you think it is. This is the beautiful, strange, counterintuitive thing about sound that took me years to really appreciate in the way nature actually works, not in the way we casually describe it. Let me start with what everybody learns in school. Sound is a wave. Fine. Waves travel through air. Okay? You make a noise. The air carries it to someone else's ear. That is the story we tell. But that story misses the most important part. The part that reveals something deep about reality itself. The air molecules themselves are not traveling from your mouth to someone else's ear. Not at all. In fact, the individual air molecules barely move at all. They just wiggle back and forth, maybe a fraction of a millimeter, right where they are. It is like if you and I were standing in a long line of people, and I pushed the person next to me, and they pushed the person next to them, and so on down the line. The push travels down the line fast, really fast. But none of the people actually walk down the line. They just bump into each other and pass the push along. That is what sound is. It is a pressure disturbance, a pattern of compression and rarefaction moving through a medium. But the medium itself is not going anywhere. The molecules just dance in place. Now this seems like a technical detail, but it is not. It changes everything about how we should think about what sound really is. Because if the molecules are not traveling, then what is traveling? What is this thing we call sound? Here is where it gets really interesting. Sound is information. It is a pattern. It is organization moving through matter, but it is not the matter itself. Think about it like this. Imagine you have got a long row of dominoes set up. You knock over the first one, and the falling pattern moves down the line. The pattern of falling moves fast, zip, 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 but each domino just tips over right where it stands. The falling, the pattern that moves. The dominoes do not. Sound is like that. It is a pattern of high pressure and low pressure regions moving through the air, but the air itself just sits there and vibrates. Now, why does this matter? Why am I making such a big deal about this? Because it reveals something fundamental about waves in general. And once you understand this about sound, you start to understand light differently. You start to understand water waves differently. You start to understand everything in nature that involves wave motion differently. The medium and the message are not the same thing. The thing doing the waving and the wave itself are two completely different entities. Let me give you another way to think about it. When you look at ocean waves, what do you see? You see water moving toward the shore, right? Big walls of water rushing in. But if you put a cork in the water, what does it do? It bobs up and down. It does not rush toward shore. The water molecules are going up and down, in little circular patterns actually, but the wave pattern that is moving horizontally toward the beach. The wave is not made of water traveling horizontally. It is made of water moving vertically, and that vertical motion creates a pattern that propagates horizontally. Sound is the same idea except in one dimension instead of two. Now here is where Feynman, that is me, got really fascinated by this when I was learning physics. If sound is just a pressure pattern, then what determines how fast it travels? Why does sound move at about 340 meters per second in air at room temperature? Not faster, not slower, but right around that speed? And the answer is beautiful. It depends entirely on how fast the molecules can communicate with each other. How quickly can one molecule bump into the next one and pass along the message, hey, high pressure coming your way, get ready. That speed depends on two things. First, how massive the molecules are. Heavier molecules are lazier, they accelerate slower when pushed. Second, how stiff the connections between molecules are. In air, there is no real connection. The molecules are just bouncing around freely, so the stiffness comes from how hard they collide based on temperature. Higher temperature means faster random motion, which means faster collisions, which means the pressure wave can propagate faster. That is why sound travels faster on a hot day than a cold day. The molecules are already zipping around faster so they can pass the message along quicker. But here is the kicker. In liquids and solids, where molecules are actually bound together, sound can travel way faster. In water, sound moves at about 1,500 meters per second. In steel, it is more like 5,000 meters per second. Why? Because the molecules are connected. They do not have to wait to bump into each other randomly. They are already touching, already bound. So when you disturb one, the neighbors feel it instantly through those bonds. It is like the difference between a line of people holding hands versus a line of people standing apart. If they are holding hands, a push gets communicated way faster. Now let me tell you something that nobody talks about but absolutely should. Sound cannot exist without a medium. This is not some technicality, this is fundamental. In the vacuum of space, there is no sound, not because space absorbs it or dampens it, but because there is nothing there to do the wiggling. There are no molecules to compress and rarefy. The whole concept of sound falls apart. You cannot have a pressure wave without something to have pressure in. This is completely different from light. Light does not need a medium. Light is a self-sustaining oscillation of electric and magnetic fields, and fields exist everywhere, even in perfect vacuum. But sound? Sound needs stuff. It needs matter to wave through. This is why in all those science fiction movies, when you hear explosions in space, it is complete nonsense. There is no air in space, no molecules, so no sound. The explosion would be silent. You would see the flash, you might feel the radiation if you were close enough, but you would not hear anything. Hollywood gets this wrong every single time because our brains are so wired to associate big events with big sounds that silence feels wrong. But nature does not care what feels wrong to us. Nature just follows her rules. Now let me take this deeper. When we say sound is a wave, we need to be precise about what kind of wave. Sound in air is a longitudinal wave. That means the vibration of the molecules is parallel to the direction the wave travels. If the wave is moving to the right, the molecules are vibrating left and right, back and forth along that same axis. This is different from, say, a wave on a string, where if the wave moves horizontally, the string moves up and down. That is a transverse wave. Water waves are actually a mix, kind of a hybrid, but sound in gases and liquids is purely longitudinal. Compression, rarefaction, moving along. Now here is something really subtle that took me forever to wrap my head around. When you have a pure tone, a single frequency, what you really have is a repeating pattern of high and low pressure regions moving through space. Imagine it like this. You have got regions where the air is squeezed together, high pressure, and regions where it is pulled apart, low pressure, and these regions are moving through space at the speed of sound. The distance between two high-pressure regions is the wavelength. The number of times a high-pressure region passes a fixed point per second is the frequency, and here is the beautiful part. Wavelength times frequency equals the speed of sound, always. That is not a coincidence. That is just mathematics describing how wave patterns work. But what determines the frequency? What makes one sound high-pitched and another low-pitched? It is all about how fast the source is vibrating. If you pluck a guitar string, the string vibrates back and forth. Every time it moves forward, it compresses the air in front of it. Every time it moves backward, it rarefies the air. So the frequency of the sound wave is exactly the same as the frequency of the string's vibration. A thick, heavy string vibrates slowly, low frequency, low pitch. A thin, tight string vibrates quickly, high frequency, high pitch. The sound wave is just a copy, a record of the source's motion. Now, this brings up something fascinating. What happens when you have two sounds at different frequencies? Do they interfere? Do they combine? And the answer is yes, they absolutely do. This is called superposition. If you have two pressure waves traveling through the same air at the same time, the total pressure at any point is just the sum of the pressures from each wave. If both waves are compressing the air at the same spot at the same time, you get extra compression. If one is compressing and the other is rarefying, they partially cancel out. This is how noise-canceling headphones work, by the way. They detect the incoming sound wave and produce an exact opposite wave, so when you add them together, you get silence. But here is where it gets weird. Even though the waves add together, they do not actually affect each other. After they pass through each other, they just keep going as if nothing happened. Two sound waves can collide, interfere, create complicated patterns, and then separate and continue on completely unchanged. This is totally different from, say, two balls colliding. When balls collide, they bounce off each other, they change direction. But waves just pass through each other like ghosts. That is one of the most mysterious and beautiful things about wave phenomena in general. Now let me tell you about something that absolutely fascinated me when I first learned about it. The speed of sound is not constant in the sense that it is the same everywhere. It depends on the medium and the conditions. I already mentioned temperature, but it also depends on pressure, humidity, wind, all kinds of things. And this creates some really strange effects. For example, sound bends. If you shout across a lake on a cold morning, your voice can travel much farther than usual. Why? Because the air near the water is colder than the air higher up. Sound travels slower in cold air, so the top of the sound wave up in the warmer air moves faster than the bottom of the wave down in the cold air. This makes the wave bend downward, staying close to the surface instead of spreading up into the sky. It is like if you are pushing a shopping cart, and one wheel is on smooth pavement and the other is on rough ground. The cart turns toward the rough side because that wheel is going slower. This bending of sound waves is called refraction, and it is exactly the same principle that makes light bend when it goes from air into water. Different speed in different media. So the wave changes direction. Nature uses the same trick over and over again in different contexts. Once you see the pattern, you see it everywhere. Now here is something that really gets to the heart of what sound is and why the common understanding is so wrong. People think sound is a thing, like an object. They think it is something that exists independently, that you can point to and say, there is the sound. But sound is not a thing. Sound is a process. It is an event. It is something happening, not something being. The air is always there. The molecules are always there. But the sound, the pattern, the organization, that only exists when the molecules are doing their coordinated dance. When the dance stops, the sound stops. There is no sound left over, no sound hanging around. The pattern disappears, and all you have got left is air. This is a deep idea. It applies to so much more than just sound. It applies to life itself. What is life? Is it the atoms? No, the atoms are just atoms. You and I are made of the same kinds of atoms as a rock: carbon, hydrogen, oxygen, nitrogen. The difference is not the atoms. The difference is the pattern, the organization, the process. Life is what happens when atoms are arranged in certain specific ways and are doing certain specific things. When the process stops, the life stops, even though all the atoms are still there. Sound is a simpler version of the same idea. It is pattern and process, not stuff. Now, let me talk about something that is going to sound crazy, but is absolutely true. Sound does not exist until it is observed. And I do not mean observed in some mystical quantum mechanics sense. I mean something much simpler. Sound is a physical pressure wave, absolutely. That exists whether anyone is listening or not, but the experience of sound, the pitch, the loudness, the timbre, that only exists in a brain, your eardrum vibrates in response to the pressure wave. That vibration gets converted into electrical signals in your cochlea. Those signals travel to your brain, and your brain interprets those signals as sound. The interpretation, the qualia, the subjective experience, that is not in the air, that is in your head. So here is the question. If a tree falls in a forest and no one is around to hear it, does it make a sound? The answer is yes and no. It makes a pressure wave, absolutely. But it does not make a sound in the sense of an auditory experience, because there is no ear and brain there to create that experience. The pressure wave is the physical reality. The sound is the perceptual reality. They are related but not identical. This is not just philosophy. This is important. It means that sound is partly physics and partly biology. The physics is the wave. The biology is the hearing. And here is another twist. Different animals hear differently. A dog hears higher frequencies than you do. A bat hears even higher. An elephant hears lower frequencies than you do. So the same pressure wave can be sound to one animal and silence to another. The wave is the same. The experience is different. Which one is the real sound? Both are. Or neither is. It depends on what you mean by sound. This ambiguity is not a flaw in our language. It is revealing something deep about the relationship between physical reality and subjective experience. Now I want to come back to the original point, the big misconception. The misconception is that sound is a thing that travels, that when you talk, little bits of sound fly through the air to someone else's ear. That is not what happens. What happens is you create a disturbance. That disturbance propagates through the medium as a pattern. The pattern reaches someone else's ear. Their ear detects the pattern and sends signals to their brain. Their brain interprets the signals, and they hear you. At no point did sound, as an object, travel anywhere. The air vibrated, that is all. The vibration carried information, and that information got decoded at the other end. This is why sound is such a perfect example of wave behavior, because it makes it clear that waves are not things. Waves are processes. They are patterns moving through things. And once you understand that about sound, you understand it about all waves. Water waves, light waves, quantum waves, whatever. The wave is not the medium. The wave is the pattern in the medium. And the pattern can exist, propagate, interfere, diffract, do all kinds of amazing things, even though nothing physical is actually traveling very far. There is something almost magical about this. You can shout, and someone 100 meters away hears you. The information traveled. Your words, your meaning, your emotion, all of that traveled through the air. But the air itself did not go anywhere. The molecules just wiggled in place. And yet, the message got through. That is the miracle of waves. They allow information to travel without requiring matter to travel. They allow patterns to propagate. And patterns are incredibly powerful because patterns can carry meaning, structure, organization, all the things that make the universe interesting. So the next time you hear a bird sing or a car horn honk or your favorite song on the radio, stop for a second and think about what is actually happening. The air around you is dancing. Molecules are vibrating in incredibly complex, coordinated patterns. Those patterns are encoding information. Your ears are detecting those patterns. Your brain is decoding them, and you are experiencing sound. But the sound is not out there in the air. The sound is in your head, created by your brain in response to pressure waves. The waves are real, the sound is real, but they are not the same thing. That is the big misconception about sound. People confuse the wave with the experience. They confuse the medium with the message. They confuse the physics with the perception. And once you separate those things, once you see them clearly for what they are, the whole phenomenon becomes so much richer, so much more interesting, so much more beautiful. Because you start to see that sound is not just vibrating air. It is a bridge between the physical world and the mental world. It is how patterns in matter become thoughts in minds. And that is pretty incredible when you think about it.